I'm going to be teaching you about the physics of the piano. First, we're going to start off with some history about the piano. The piano is a percussion instrument that's been around for about 300 years. However, before the piano was invented, there were earlier forms, such as the hydraulis, the clavichord, and the harpsichord. The hydraulis was invented by a Greek engineer named Ctesibius of Alexandria, and it was the first musical instrument with a system of manually operated piano key notes. It was invented around 250 BC, and it used an air compression mechanism that was powered by water. And here's a picture of the hydraulis. The clavichord was invented in the early 1400s, although it's unclear who the exact inventor was. With this instrument, brass and iron strings will be struck with small metal blades called tangents, and this produced vibrations which were transmitted through the bridge to the soundboard. The name of the clavichord comes from clavis, meaning key, and cordis, meaning string. Here's a picture of the clavichord. The harpsichord was invented in medieval times, and is again unclear who the exact inventor was. With this instrument, the strings were plucked instead of being struck, and there were no dynamics with the harpsichord, so it couldn't play loud or soft sounds. Here's a picture of the harpsichord. The first piano was invented by Bartolomeo Cristofori in Italy around 1700. With this instrument, the pegs were replaced in the harpsichord with felt hammers, allowing for loud or soft dynamics. The name of this was originally Gravicembalo col piano e forte, meaning a large harpsichord with soft and loud. This was eventually shortened to forte piano or piano forte, and then just a piano. This form was a grand piano in which strings run parallel to the floor. However, Johann Schmidt created the first upright piano 50 years later, in which the strings run vertically. Here's a picture of a grand piano and an upright piano so you can see the difference. Today we have over 50 brand names of pianos, including Fenway, Baldwin, Steinway, Yamaha, and many others. Throughout the past century, there have been 5,000 different brands of pianos on the market. Today we also have digital pianos which run on electricity. Moving on to the parts of the piano. The piano has 88 keys, 52 of which are white and 36 which are black. It also has 3 pedals: a damper which holds notes for a long period of time, the sostenuto which sustains certain notes, and the soft pedal which mutes notes. There are also 230 steel wire strings, along with felt hammers and dampers, which produce the sound. Sound transfers through the wooden bridge to the soundboard, which vibrates the air around it, creating a louder noise. The piano also includes the housing and the lid, and on grand pianos, opening the lid gives a louder, more resonant sound. There are over 12,000 parts in a piano, 10,000 of which are moving. Okay, so here's my piano, and this is an upright piano, and everybody knows what it looks like from the outside. It has all the white and black keys, as well as the 3 pedals underneath. But I'm going to show you inside the piano when we lift up the lid. Now inside it's really dark, so I'm going to use a flashlight to show you all the hammers and strings and all the pegs. Now you can see how the hammer hits the wires when you play keys on the piano. Now when I hold a note down longer like this, the damper doesn't release onto the string until I lift up my finger. And if you're wondering, these are the dampers. However, when I hit a note quickly like this, the damper quickly hits the strings so that the sound stops and the string stops vibrating. Now I'm going to show you what happens when we hold down the damper pedal. When I push down on the pedal, it releases all the dampers like this. This way I can freely play as many notes as I want, and the sound will continue to vibrate in all of the strings. The sound doesn't stop until I release the pedal. Now I'll show you what happens when we hold down the soft pedal, which is this one on the left. When I push down on the soft pedal, it brings all of the hammers closer to the strings like this. This way, when I play notes, the hammers will hit the strings with a lesser velocity, and this will create a softer sound. So this is without using the soft pedal. And this is with the soft pedal. See the difference? Using the soft pedal allows musicians to play a softer piece more easily. Now I'm going to talk about how the sound is produced in a piano. When you press the key on the piano, a hammer inside hits a string, causing it to vibrate. This vibration creates sound. This all occurs in a split second. Sound variations are caused by the length, tension, and thickness of the string. So, a longer, looser, thicker string would produce a lower velocity, frequency, and perceived pitch. A shorter, tighter, thinner string produces a higher velocity, frequency, and pitch. Most strings on a piano are not only longer, but thicker as well. This is because if all the strings had the same thickness, the lowest key would have to have a string of 30 feet long. Therefore, the lower strings are wrapped in copper or iron wire around the core wire. Now, if you see the wires right here, you can see how they progress from very thin to thicker and thicker, as well as longer, and then eventually you can see how they are covered in copper wire. And the last notes are very thick. Newton's first law explains how the piano works. This law states that an object at rest will stay at rest unless acted upon by an outside force, or that an object in motion will stay in motion unless acted upon by an outside force. Well, in the piano, a string will stay at rest until the hammer hits it, and the string will stay in motion until the damper stops it. Now, as for the physics of sound waves. Sound is the vibration of a substance. So this vibration moves through the molecules in waves. Molecules bump into each other. This causes the material to alternate between more and less dense in certain areas. When it's more dense, this is called condensation, and when it's less dense, this is called rarefaction. And here's a picture that explains that. And the only place that sound cannot travel is in a vacuum. Now, our ears collect these vibrations and use them to interpret sound. And the power of sound of the piano at fortissimo, the loudest dynamic, is 0.1 watts, which doesn't sound like much, but it actually surpasses the power of any other stringed instrument. Now let's talk about the physics of major and minor, loud and soft, and high and low pitched chords. Now, a regular sound wave has peaks and troughs. When you add a note and it's a minor note, these two waveforms create an odd curve. This curve has a slight spike at the peak. The gap between the peak and the spike creates an internal frequency that is unpleasant to the ear. This is a minor chord. However, with major chords, the addition of new waveforms do not create these spikes. Therefore, the sound is pleasant. Loud and soft sound depends on the human threshold of hearing, as well as the frequency and intensity of the sound. Hitting keys harder creates a greater amplitude in the waves, causing a louder sound. The frequency of the first note of each octave doubles as you move from left to right on the keyboard. Therefore, the lower the frequency, the lower the pitch, and the higher the frequency, the higher the pitch. In terms of the waves themselves, a louder note will produce a wave with a greater amplitude, and a softer note will have a smaller amplitude. And as for the pitch, a higher pitched note will have shorter wavelengths, and a lower pitched note will have longer wavelengths. I have a picture that illustrates this. It also shows the difference between a major chord and a minor chord in the way that they look. Now here are some interesting facts about the piano. The piano is sometimes referred to as the king of instruments because of its wide tonal range, its ability to play the melody and accompaniment simultaneously, and its broad range of dynamics. It is also one of the largest musical instruments. Each string inside a piano has 165 pounds of tension. All the strings combined have a total tension of approximately 18 tons. The saying "tickle the ivories" refers to playing the ivory keys of a piano. However, ivory has not been used to make piano keys since the 1950s. They are now made of plastic. And studies show that children who play the piano do better in school because of the discipline, hand-eye coordination, social skills, and new language that it teaches. And this language is music. So I hope you learned something new about how the piano works. And now I'm going to play a song for you called Everything by Michael Bublé. I hope you enjoy.